about nature has swung between two opposing points of view. First, the universe obeys fixed, immutable law and everything exists in a well-defined objective reality. Second, that all is flux, all is change. As Heraclitus says, you can step in the same river twice. Science has largely governed by the first rule, but ways of thinking as diverse as postmodernism, cyberpunk, and chaos blur the objectiveness of reality.
Newton's mathematics find the first significant step toward a worldview that transcends and unites both rigid law and flexible flux. Kepler and Galileo also realized that change obey rules. Not only can law and flux coexist, but law generates flux and flux generates law. Prior to Newton's mathematics have offered an essentially static model of nature, but Newton changed it all the way by stating his law of motion.
Mass by acceleration equals force. The simplest theory consistent with this measure of real experiments and thought experiments is that when a force acts on a body, the body experiences an acceleration that is proportional to that force. And the only missing piece is the assumption that is always true. A historian's urge, when confronted by a historical theory, was to solve it or know the facts behind it. Hence, a mathematician, when solving a problem, was to solve it. But how? Solving an acceleration, which is a constant, won't give us a hint. About the shape of trajectory is where the calculus comes in.
Calculus, an advanced branch of mathematics that deals mostly with rate of change and with finding lengths, areas, and volumes through the use of a technique called integration. Calculus provides a technique for finding rates called differentiation. Integration and integrating twice undoes the effect of differentiating twice. This states that if you know the function of a factor, you can find the answer for the other. All of it was
The laws that they observe and the law that produce it is crevasse, which the human mind can reach only by mathematical calculations. As said by Paul Dirac, God is a mathematician. Maybe nature patterns and regularities have other regions, but at the very least, mathematics is an extremely effective way for human beings to come to grips with those patterns.
All the laws of physics that were discovered by pursuing Isaac Newton's basic insight that change in nature can be described by mathematical process, just as form in nature can be described by mathematical things. All laws formulated after Isaac Newton's law was not about physical quantities, but various rates of changes.
Newton solved Kepler's discovery after discovering an important natural patterns. The law of gravitation, hence the inverse square law, was coined. However, this law was only applicable to two moving bodies. Three-body motion was yet to be discovered.
over time, the view about mathematics was changed. The word solve was given different meanings. First, the word means find a formula, then find approximate problems, and lastly, tell me what it looks like. But this change was not a retreat for what change of meaning has taught us, is that for questions like the three-body problem, no formulas can exist. We can prove that there are qualitative aspects to the solution that formula cannot capture.